Hi, I'm Kevin Gallagher, Technical Marketing Engineer with F5, and I'm here to talk to you about DNS over HTTPS detection, which is an advanced use case for SSL Orchestrator. Let's go ahead and get started. First of all, you might not know, but what is SSL Orchestrator? Well, it's basically centralized SSL and TLS decryption, and then when that content is decrypted, it is distributed to a variety of security and visibility tools, some of which you're probably familiar with, like Palo Alto Networks, Next Generation Firewall, RSA Net Witness, Cisco WSA, Cisco Firepower, NetScout, Symantec DLP, and even F5 products. Regarding the evolution of DNS to DOT and DOH, you don't really need to know all the ins and outs of how exactly these work. It just helps to understand that basically in the old days, on the left here, DNS was in clear text, and it could be visible to virtually anything in the path between you and your DNS server. So it lacks privacy. And basically with DNS over TLS and DNS over HTTPS, it's basically just encrypted. So it can't be recognized by most security tools and will simply pass through. So why is this important? Well, there's some security implications of encrypted DNS. There's the notion of improved user privacy, which I'll also address a little more later. It also leads to ISP or corporate reduced visibility. And partly because of that, you have reduced performance because you can't do your traditional caching of DNS requests, which leads to reduced visibility in analytics. If you can't recognize it as DNS, you don't know that it's occurring, you don't know how much it's occurring. And also in terms of the improved user privacy, there is the notion of that, but you have to realize now that your DNS patterns are being exposed to third parties like Cloudflare and Google, as opposed to maybe your corporate proxy or ISP. And of course, since you can't recognize this encrypted content, it leads to reduced security controls. It can actually lead to masking of command and control communications. Since most firewalls and proxies and security devices don't yet recognize or control DNS over HTTPS, then the bad guys can actually use this to mask their connections to command and control communications. Now, Big IP 16.1 delivered the ability for a DOH proxy and a DOH service. It allows us to recognize a DOH request, and it allows us to consume the request and convert it to regular DNS. That way we can actually cache any of the responses that we get. All right, next I'm going to show you a little lab environment so you can see what this looks like. All right, in this lab environment, we have an SSL Orchestrator configured with an L3 outbound topology, and you can see we have a FireEye service there for inspection. Now, this technology is mostly based off of iRules. This particular iRule is the one that you edit so that you can enable logging, you can enable high-speed logging, and you can also do what's called black holing over here, and we'll go over that later. And this is all based on this DevCentral article from Kevin Stewart, SSL Orchestrator Advanced Use Cases, DNS over HTTPS detection. And this has all the instructions for how to set this up, give you a little bit of information on it, and give you the iRules that you can use to test this. And we want to enable the log. All right, so here I am on the Ubuntu client, and I've got a bunch of different CLI commands I'm going to send to simulate these DNS over HTTPS and TLS requests. So we'll go ahead and get started. This way you can see what the request looks like, what the response looks like. You can see it got this particular IP address here as a response. And if we look over at the tail, we can see here that this DOH request was sent for example.com, and that IP address was returned. We've got a couple different ones we can try as well. Here you can see the query for the A record, example.com. There's even a TTL returned, so time to live, and then the answer, the same IP address we saw before. And then if we look at the log here, we can see that it was a DOH request in the wire format GET. All right, let's try another one. All right, so this verbose one gives a little more information. You still get the IP address here that's returned for the DNS request, but you can actually see the verbose, like exactly what the request looked like when it was sent. Now we'll try one utilizing Cloudflare. And you can see we get that same DNS response. And let's double check here. I forgot to look at the access log format. And you can see that the request was recognized here. And we'll try this next one. Again, you can see the correct IP was returned. And we can see that the big IP logged the request and recognized it. All right, here's a slightly different one. You can see that it returned an A record, which is normal, and that it went to this Cloudflare DNS host using HTTPS. And you can see the full GET request here. And then the query was for example.com. This little number here is the TTL. This is the representing that it is an A record, which is normal. And then, of course, there's the IP addresses there. Now let's try a couple others here. You can see this returns a full like HTML page, and you can see some of the information that's there. And if we look back at the log here, we can see that it was a DOH request previously for example.com, and then this one here was actually, and these were posts, so it can come in many flavors. Let's try some of the DOT requests. All right, so the request was here. You can see some debug TLS info. Obviously this was sent to dns.google. We can see the query was for example.com, at the A record, and there is of course the IP address. And if we look over here, we can see that it was recognized as a DOT request for example.com. Similar to that one, example.com, same IP address. And if we look over here, we can see it was a DOT request. So now what we're going to do is take a look at this, the black hole setting we were talking about before. And this allows you to return basically a fake answer to DNS requests that are sent over HTTPS and TLS. And I'll show you what that looks like when the policy is used. And don't forget to click Update. All right, so I'm going to come over here. There we go. So in this request, we can see that it was for example.com. We've got a TTL there returned. It was an A record. You'll notice now this IP address is different. It's 199.199.199. Totally bogus. If we look back at the log, we can see that the DOH request was recognized. We can see that the big IP realized that this was for something to be black hole and sent it the bogus fake response. I'll try a couple more just to show. And you can see that as well, the 199 address. So if you needed to prevent these requests from going out, this is one way to do it, is just return a bogus answer. That is really all that there is to the demo here. I wanted to be brief and get you guys the information that you need to understand this. Thank you for taking the time to view this demo.